What's going on, guys? It's your boy Kid October back with another video, and today we are looking into the basics of Thunderstorms, and we're starting off with Supercells. This is a series that I'm going to be doing for all those people out there who want to learn about Supercells and Thunderstorms and want to pursue the career of being a meteorologist like me, or just a really good storm spotter. That's the current stage that I'm in right now. I wouldn't call myself really good. I just call myself a professional. But let's start off. Now supercells are the result of atmospheric convection. So convection in the atmosphere is when the sun's energy heats the ground surface, and the warm ground heats the air above it, so it causes it to rise. But as it rises into the cooler atmosphere, it begins to cool down, and when all this hot humid air, once the temperature reaches the dew point, it forms clouds. But when it reaches the equilibrium level, the rising air cools and it begins to sink, causing this loop to happen all over and over again. And this is another thing that I'm going to be putting in all videos. So this is a chart of dBz, which is a scale used for weather radar. So from 5 to 15, it could be mist or accumulation. From 20 to 25, it's typically light rain. So like right here. 30 is like light to moderate rain. And 35 is just moderate rain, which is getting into the yellows. 40 is moderate to heavy rain. And 45 is heavy rain, which is getting into the oranges and reds. 50 is heavy rain, and small hail is possible, so right here. And 55 is heavy rain, very heavy rain, hail possible, so right here. 60 is very heavy rain, hail likely, so right here. 65 and above is very heavy rain, hail very likely, large hail possible. Now let's move on to supercells, shall we? A typical supercell environment there'd have to be a low pressure system with an upper trough along with an upper ridge, so a high pressure ridge right here and a low pressure ridge down here, or trough. You got that polar jet stream moving through, allowing for cold air to dip down and causing this cold front, while you have this low level jet and the southern jet stream moving in, bringing this warm air wind, which is causing this warm front. So since you got that low level jet, warm humid air is going to be rushing in, and when cold dry air meets, it creates convection, which rises heat, causing clouds and thunderstorms. And since you got that low level jet and this wind's going this way, you're going to get some supercells. And this orange area is where severe thunderstorms and supercells are possible, along with tornadoes. Now, this is a cyclic supercell. A cyclic supercell is a supercellular thunderstorm that goes into a cycle. The rear flake downdraft begins to form as the updraft is intensifying. And you got that flow 4 kilometers and then 9 kilometers. This way's north and east. So since you got all that wind shear, the atmosphere is going to start, the updraft is going to start spinning. Now, this rear flank downdraft, it hits the ground and it begins to spread, and this updraft intensifies because this cold air is beginning to squeeze the inflow in, creating more of a notch. But once that increases, you get more rotation, and you get this couplet, and you can see that there's this tornado. That's that purple line. But as the rear flank downdraft increases, it's going to kill off that old updraft, but a new updraft is going to try and develop. but that new updraft is going to take some time, so this rear flank downdraft is going to start dying out, causing this whole thing to happen again. Now here's the characteristics of a mesocyclone. Mesocyclone is a rotating updraft in a thunderstorm, which is typically strongest in the mid-levels. Rotation develops as environmental horizontal vorticity tilts and accelerates into vertical. Storm dynamic process is important. Parent circulation that can lead to a tornado, and which is necessary but not sufficient for a tornado. If you want a tornado, you must have strong low-level rotation. Supercells or mesocyclones can last for hours, associated with EF0 to EF5 tornadoes. Almost all violent tornadoes are associated with mesocyclones, and you can see that this low-level and mid-level, cyclonically rotating updrafts. So the radar is to the south. Here's the classic supercellular structure. So here you got that flanking line, which is a line of convection, as some people call it. You got the leading edge of this RFD here, and you got the tornado location, which is in between the RFD and the inflow. You can see that there's very large hail in here, up to 5 inches possibly. Oh yeah, and you got the leading edge of the forward flank downdraft. By the way, this is the West Liberty, Kentucky supercell on March 2nd, 2012. So the RFD wrapping around the mesocyclone and the backside of the storm is right here. It's this green. And that low-level mesocyclone is, and the tornado location is right here. And you got that storm relative inflow into the updraft, which is right here. Oh, sorry, I skipped ahead a little bit. This is the most uncommon but most dangerous storm type. Produces almost all instances of very large hail and violent tornadoes. They are highly organized due to strong environmental vertical shear and dynamic process in storms. Buoyancy is important, but less so than a pulse/mesoscale convective system storms, since supercells are dynamically controlled. They tend to have a long life cycle. 1 to 4 hours is quite common. That's how the name supercell was obtained, because of duration of the storm. And supercells can have to contain a strong sustained rotating updraft, which is a mesocyclone. Now, important concepts of a supercell is mesocyclones, hook echoes, weak echo bounded regions, bounded weak echo weak echo region. Wait a second. Weak echo regions, bounded weak echo regions. And then the creation of rotation and updraft, dynamic process, forward flank downdraft, rear flank downdraft, splitting storm, aka left and right movers, wall clouds, tail clouds, and Amatis clouds, and a V-notch. Now here is an artist rendition of a low precipitation supercell. Little to no rain, typically like a dry storm, a dry supercell. So you got that. You can't really see it here, but you got that. You got that RFD. This is a low precipitation supercell. Then you have a a classic supercell, and you got that tail cloud and that flying saucer shape, and you can clearly see the RFD and the forward flank downdraft here. And now this is a high precipitation supercell. Shelf clouds going through most of the storm base. We'll go into more detail on what shelf clouds are. Now, one thing that I do want to mention is that the shear on this can create this weird looking effect where this flying saucer shape is at the bottom, but it kind of splits off here, and it's like this bubbly cloud kind of shape, and this is typically the same for all supercells. Now I want to go into detail on how the wind shear and the updraft is created. Not the updraft, but so the wind shear, this wind shear here makes the air spin, which is horizontally spinning. And then the updraft bends the spinning air upwards, rising it from horizontal to vertical. And then the updraft starts rotating with the spinning column of air. And that's how tornadoes and supercells are formed. Now that's really all I want to get into. I will be doing a part 2 to supercells, just not here. This is only the basics. We're going to do an advanced version soon, where we get into more detail about this. I know this was pretty advanced, but this is really only the basics. Well, that's going to wrap up today's video. Hope you guys enjoyed. See ya, and subscribe and like the video and comment if this is... oh god, I'm about to burp. Comment if you want to see more videos like these. And I will be taking suggestions, so suggest anything that you want. I will try and make a different channel where I do storm chasing. That probably won't be till next year. Even though I'm in the region where above average severe weather is said to happen this fall, which is like the Chicago-Milwaukee region. But yeah, that's going to wrap up today's video. Hope you guys enjoyed. See ya and goodbye.